Greeting viewers. Rockfall in open pit mines is not just a geological condition, it is an operational threat with human consequences. With a country like India, where we have 18 open pit mines spread across 11 states, predicting rockfall is not just a necessity, but it is very essential. So we ask ourselves a question, can we do it? And the answer is yes. We gather many multimodal data from various aspects such as rainfall, seismic vibrations, earthquakes, and many others. We put together all those data to make a big data set and then feed that to our ensemble learning model in order to predict it. This is a very efficient solution. As we know, rockfall is a very climatic disorder where it can take lives of millions of people as well as cost us heavy equipmental loss that will cost us both life as well as financial issues. So here we come up with a dashboard that will enable us to solve our problem. We have total three kinds of users: admin, mine supervisor, and mine operator. Now, currently we are logging in through the admin user. The admin needs to give it username and its password in order for a secure sign in. And then when we click sign in, we get inside to a main dashboard screen. So here we currently signed in. Now on the top, we can see critical alerts. 5 mines are at high risk at the current position, which shows that among the 18 total mines in India, 5 mines are at high risk currently. Then coming up to the dashboard's nav bar. The nav bar contains 4 models: overview, alerts and actions, analytics, and model info. In the current section of overview, we can see there are 4 sections of high risk, medium risk, low risk, and the last one contains 18, the value of total mines India has. Throughout the presentation, we will represent red as high risk, orange as medium risk, and green as the low risk. So currently, there are 5 high risk mines, 4 medium risk mines, and 9 low risk mines. Then coming up to the map, this is the current risk map. We can see different parts of India having mines with red, green, and yellow color, red, green, and orange color representing their true nature. On the right hand side, we have weather alerts as well as active alerts. Those active alerts are for the mines explicitly. When we below that, when we press refresh alerts, the alerts will be refreshed. And we have also SMS system that shows the direct SMS test that will help sending direct SMS to the mines. Then below it, we have the risk trends for the past 7 days. Here are the graphs with different colors accordingly set that shows what is the risk in the last 7 days for those all mines. And beside that, we have also the details of the mines. For example, the current high risk mine is the Talcher coalfield present in Anugu, Odisha. Here the risk is currently low, and every sensors that we have deployed, displacement, seismic cracks that have been collected through the data sets have been shown there. Here comes the complete representation for the overview bar. Then coming up to the next bar, that is alerts and actions. The alert and action bar critically shows the critical alert mines specifically, then the medium alert mines and the lower alert mines. Beside that, we have also emergency action plans that the peoples who are present at the mine should take according to their mine risk. We have 3 different kind of action plans for high risk, low risk, and medium risk as well. This will help them prepare themselves. If some situations will come, accordingly they will behave, and which can save their life and the instrumental cost as well. We have also a AI risk analysis that will analyze the risk for every particular mine we have given. That is the total 18 mines India has, with a confidence ratio below that shows how much risk of that particular kind the mine is currently in. Here we can show that different mines with different ratios of confidence and different alerts. This way, every mine details we have in the dashboard. Coming up to the next nav bar, next tab, that is analytics. Analytics tab shows different charts as of contour charts, pie charts, bar charts that will be representing every details about the mines and their risk analysis. As I already said, the color representation for every mine is same. We here have monthly alert trends, real-time sensor data, distribution across mines, state-wise rank analysis, and many more, for a clear and a pictorial representations of what happening in the current mines and every data they have. The best part of our project is we can get the real-time sensor data, which you might have seen is changing according to the current scenarios and situations. That is that is the biggest novelty we can ever show in our project, because our project will work on a real-time basis, hence providing better accuracies. Coming up to the last part of our project, that is the details of our model itself, that we have stated model info. The model info tab clearly represents every particular model we have presented. The first and the basic model that we have used is cat boost having every selection criteria and everything, with a training accuracy of 94.5 and a ROC score of 0.83, that is 83%. The cross validation score for our validation test set seems 0.82, that is 82%, which is a really nice score. You can see our model performance as precision and recall going out with 0.92, the F1 score also going out with 0.92, and a AUC ROC score of 0.83. As we have already stated that we have used an ensemble model, that is we have used 6 total models in it. The first model being the cat boost primary, then come up with XGBoost, light BGM, AdaBoost, MLP, and random forest. All these models will be particularly based on a primary model, but this novelty of ours enable us to use any other model if at a particular time our particular model fails. And together all these models help us giving the best accuracy that can be possible. Apart from that, we have also deployed a real-time sensor-based hardware device, that is a IoT device, which will be later connected with YOLO and CNN, that will be fitted in the real-time ground zero mines, that will enable us to get more accurate and more precise result regarding our project. Whenever any kind of critical situation will be predicted, the buzzer and the other parameters of our IoT device will help us evacuate that particular place, which will help us reduce life and cost also. So our project consists of a good hardware and a brilliant software. Together, this makes a great combination that can predict and prevent the cost of life and instruments from the rockfall as much as possible. We hope this will help the society and the peoples in a great way. Thank you.